During this period, NASA plans to launch a new telescope into space. This new telescope is the product of 20 years of international collaboration, completed by leading scientists and engineers after many years of challenges and delays. When will the James Webb Space Telescope finally be launched? Once it begins its mission, it will be able to look into the depths of the universe like never before, becoming the most powerful space telescope ever made. What will the James Webb Space Telescope be able to observe? And what discoveries do astronomers expect from this telescope? Let's find out together. The James Webb Space Telescope, or JWST, is an extremely complex instrument. Weighing 6.5 metric tons, the telescope has been carefully folded to fit into the payload compartment of the Ariane 5 rocket that will carry it into space. This rocket will transport the telescope far beyond Earth's orbit, to a point about 1 million miles away, which is 4 times the distance to the Moon. James Webb will be stationed at a point known as Lagrange Point 2, or simply L2, on the far side of Earth from the Sun. At this point, the combined gravitational pull of the Earth and Sun will stabilize the telescope's orbit, keeping it in a fixed position relative to Earth. This location at L2 is advantageous for several reasons. First, it keeps the James Webb Space Telescope relatively close to Earth, yet far enough away that Earth itself won't obstruct the objects the telescope is trying to observe. This provides an advantage over the Hubble Space Telescope's 95-minute low Earth orbit. Additionally, James Webb has less difficulty tracking objects in the sky because its orbit is much slower. Another advantage of JWST's position is that the Sun is always on the same side of the spacecraft. The telescope is shielded by a large sun shield, allowing it to stay away from the blinding sunlight and thus obtain higher resolution images. However, being so far from Earth also brings some disadvantages. When the Hubble Space Telescope was launched in 1990, the first images it sent back were blurrier than expected. It was determined that the problem was a flaw in the primary mirror. The shape of the mirror needed to be corrected with a precision 10 times finer than a human hair. The first servicing mission in 1993 was an 11-day operation, during which astronauts performed 5 spacewalks to add new equipment to the telescope. This mission corrected Hubble's vision problem, allowing it to send back beautiful and clear images of the universe. The primary mirror of the James Webb Space Telescope is almost 3 times the size of Hubble's and promises higher magnification and resolution. However, if there is a problem with JWST's mirror, it will be impossible to fix, and the $8.8 billion investment will be wasted. Engineers and scientists are confident that the telescope will function properly once it reaches its target location. If any component does not settle correctly, or if the fragile sun shield tears, the telescope will become irreparable and unusable. This is why space agencies are ready to take significant risks with the James Webb Space Telescope. If everything goes as planned, and billions of dollars have been spent to ensure this outcome, JWST will become the most capable telescope in history. James Webb will have the largest primary mirror. This mirror, with a light-collecting area of 25 square meters, surpasses the mirrors of all other space telescopes. However, this mirror is not actually a single piece. It is a mosaic structure made up of 18 small hexagonal mirrors. These mirrors are designed to fold into 3 separate sections to fit inside the rocket. Each mirror is attached to extremely precise micromotors that can individually adjust the direction of each mirror. This system provides adaptive optics by fine-tuning the telescope's focus and filtering the images. Errors and deviations in the latest images are part of the James Webb Space Telescope's capabilities. The telescope is equipped with a series of highly sensitive infrared detectors that can see beyond cosmic gas and dust clouds, which obscure the wavelengths of visible light. Thanks to these detectors, it will be possible to see what lies beyond the dust and uncover the mysteries under cosmological redshift. Additionally, using infrared light, it is possible to study the most distant objects in the universe at longer wavelengths. The JWST team will be able to see farther than ever before. Past infrared space observatories struggled to capture the faint, red-shifted signatures from these distant galaxies because they needed to operate at very low temperatures. Otherwise, the infrared emissions from the spacecraft itself could affect the sensors and blind the telescope. Previous telescopes, like the Spitzer Space Telescope, relied on liquid coolants. However, these coolants typically ran out within a few months or years, severely limiting observation time. James Webb will not use coolants to solve this problem. Instead, it will rely on a large sun shield, an adaptive primary mirror, and a thermal radiator system equipped with powerful infrared sensors. This system will keep the telescope's temperature consistently below 50 Kelvin, or about minus 370 Fahrenheit, or minus 220 Celsius. The James Webb Space Telescope hopes to answer many of the big unanswered questions about the universe. Over the past few decades, astronomers have compiled a list of about 5,000 confirmed exoplanets. These planets orbit stars outside our own sun. However, given the great distances between us and these alien worlds, learning about these planets is difficult. While we can make some rough estimates about their sizes and orbits, JWST aims to learn much more in detail. Its infrared coverage will be used to study how starlight interacts with atmospheres. This will make it possible to determine what gases are present in an exoplanet's atmosphere. Among JWST's priorities is to investigate potential signs of life, such as water vapor, oxygen, carbon dioxide, and methane. Could the James Webb Space Telescope one day help us take a step closer to interstellar communication? Only time will tell. However, the wealth of information the telescope will provide about our galactic neighbors will be invaluable to the scientific community. James Webb will not only discover new planets, but also focus on the darkest, most distant corners of the universe. The speed of light is 300,000 kilometers per second, which is incredibly fast. But since light still travels at a finite speed, it takes time to reach anywhere. It reaches the sun in 8 minutes, the nearest star in 4 years, and it takes over 100,000 years to cross the Milky Way galaxy. Light from other galaxies can take millions or even billions of years to reach us because the distances are so vast. The farther we look into space, the further back in time we see. When you look at the night sky, you see stars and galaxies not as they are, but as their light was emitted long ago. Thanks to James Webb, we will be able to peer deeper into the past of our universe than ever before, perhaps back to the Big Bang, around 14 billion years ago, to unravel the mysteries surrounding the dark period when the first stars and galaxies began to form. It can help us understand the large-scale structure of the universe and how it has changed and evolved over time by studying the oldest galaxies. Additionally, it can provide more information about dark matter and offer some clues about the formation of challenging black holes. The James Webb Space Telescope is a massive project that has resulted from tens of millions of hours of human labor, billions of dollars of investment, and 15 years of international collaboration. With contributions from countries around the world, this is a technological marvel in itself, and it is certain that the telescope will aid in many profound discoveries in the coming years. One of the first major events the James Webb Telescope will examine is a star explosion so massive that it can be seen with the naked eye from Earth. If you want to learn more about this extraordinary event, don't miss the chance of a lifetime, and be sure to click on the video on your screen. See you there.